So when it comes to naming alkenes, we have cis and trans. And cis and trans will work good if it's the same compound. So in the case of a CH3 and CH group, we would say that this would be cis to butene. Problem is, what happens if they're not the same thing? So if you say cis or trans, what are you actually referring to? So in the event that we don't have groups relative to each other to say, how they're arranged, we're actually going to use the EZ notation. So the EZ notation, two German words, E in Integagen, which is opposite, and Zusammen, Z, meaning the same. So to determine if we have an E or a Z configuration, what we're going to do is use the Kohn-Ingle-Prelog priority rule. So I actually have a video on that. Go look it up if you don't know it. But what we're going to do is we're going to rank the compounds on the left and the right side. Now, if the high rank priority is on the same side, this is a Zusammen or a Z configuration. If they are opposite each other, meaning one is up, one is down, this is an E, Integagen, telling us that they are on opposite sides of the double bond. So for this one, it's easy. You see that it's a cis, they're on the same side, so this was a Z. But let's say we have CH3, I, and H. Well, if we look on the left side, our priority rule says that carbon is higher than hydrogen, so this is a high priority, and on the right side, this is a high priority. So this would be Z, 1 iodo, 1 propene. If we were to flip them and have the iodine down here, the hydrogen up here, this would be E, 1 iodo, 1 propene. So this is how the EZ notation works. It is a Z if the highest priority groups are on the same side of the double bond, and it is an E if they are on opposite sides. Now, the reason why we would prefer to work with this system is that the cis-trans only makes sense if the groups are the same on both sides. But the EZ system gives us a way of reliably prioritizing to know which group's going to be higher and which group's going to be lower.